After we conducted a detailed theoretical study to reach the goal required of us, which is to design and implement a device ultrasound bone density measurement. An elemental study had to be done electronic device to choose the most suitable device that are compatible with the principle of operation of the device. Okay, what about design this device? When we talk about the design, is based on defining the target to be done by the device and the required tools and means to achieve this system. A system box diagram is drawn, representing the circuits as a whole in the general, and each box separately representing a circuit that specifically meets the requirements. Each box was implemented individually and implanted the necessary circuit and how to connect them to the other group. And after searching and studying the device, we come up with this chance to simplify the mechanism of the device operation and this picture about general block diagram of the device. Each of these stages requires a set of devices that include a particle test using some means of measurement and display and means of generating analog and digital signals. So must be available from device. Signal oscillators, voltage, current and resistance scale and signal generator.
After we saw the block diagram of the device, I will start with the first circuit. Is the transmitter circuit, where this circuit takes the 40 kHz frequency formed from the fixed amplitude microcontroller and send it through its transmitter unit. The figure represents the transmitter unit. This transmitter unit represents the bus electric transmitter. The function of this stage is to convert the electrical signal into ultrasound waves. The transmitters was connected to the output frequency amplification stage, which is a MOSFET transistor, to secure the highest voltage of the transmitted signal without shifting. Resistance 8 connected to the drain transistor's bank in order to determine the current draw, while resistor 4 was connected to secure the 0-point bias.
On the other hand, there is receiver circuit. It consists of a receiving unit that represents the piezoelectric receiver and its associated elements. The function of this stage is convert signal ultrasound from one form to another. It transforms from conversion and refractions in the air into electrical signal determined by the response of the receiver to the central frequency at which it is operating.
Amplification stage. This stage divided into two stages. The initial amplification phase, its function is to amplify weak electrical signal to the point where they become strong enough to then enter the second amplification phase. This phase consists of the reflector amplifier FET type, properties of it high sensitivity and low current at the entrance. Positive amplifier input voltage bias is secured by dividing half the value of the feed using resistance 9 and 10. Secondary amplification phase to get rid of noise through the 741 operation amplifier. The final amplification is 1500 times. In addition to these two phases, the submit detection phase is added. It consists of two resistance and a frequency bus condenser. The diode D3 to extract only the positive signal, and the diode D2 to cancel the negative signal, and the C5 is just for shifting.
When we talk about processing, this stage takes place across the controller, where it is responsible for 1. Generate 14 kHz frequency and send it across transmitter. 2. Converting the signal coming from the receiver from its analog form to its digital form. 3. Display the processing result on the display screen. 4. Sound alert on input and output. And 5. Alert light when input and output. Controller. The controller has some properties. First properties, high performance with low power 8-byte word length controller. And the second properties, non-volatile program memory plus data memory.
In this slide, I will explain how the device works. When the device is turned on, we will start calibrating the maximum value and the minimum value to adjust the device parameters before starting the measurement process. Calibration is performed by cutoffs corresponding to the minimum and maximum point density. We put the first piece that represents the minimum value and press the minimum button on the device. And here, the processor generates a frequency of 14 kHz and sends it through the transmitter. So the receiver receives the signal and then amplifies it through the amplification circuit and then enter the processors to be converted from its analog shape to digital and stored to be used in the measurement process. The second piece represents the maximum value. We press the maximum button. So the device performs the same step as the previous process, but stores the resulting value with a variable that expresses the maximum value. If there is a calibration error, will appear on the screen. After making sure that the calibration is done perfectly, the device is ready for measurement. We put the hand in the space provided between the sender and receiver. We press the start button. Here the same transmission and reception steps are repeated until reaching the processor. And here the processor is shown the phrase progress to apply the measurement equations based on the point density scale confined between the value 4 and -4. After applying the equation, the result is shown on the screen as a value, and we will compare this value with a scale shown in the figure below to determine if it's osteoporosis or low point density or normal.
The device relies on sending ultrasound waves with a frequency of 5. The device relies on sending ultrasound waves with a frequency of 500 kHz through the piezoelectric component, and this type is not available in the local market, so we used a transmitter with a frequency of 40 kHz. Knowing that the device designed and implemented by us is ready to work using the ultrasound changer with a frequency of 500 kHz with some modification, like add a circuit to generate the frequency 500 kHz and addition of the thermal sensor to monitor the temperature of the part that we waves pass through.